Isn't she just adorable? Okay, let's get into our work. So today we're looking at fractions. We're going to go through 2 examples, and the third example we're just going to see what's our strategy, what's our method of attack going to be. So let's look at this one. And I mean, at first it looks completely different to what we were doing yesterday. Where the squares, where the equal zeros, where are parabolas, happy or sad? But they'll come. So let's get there. So now last year you did some kind of similar to this, and again I'm going to say this a bit, the kind of strategies that we need here. That there are a few ways to solve it. I'm going to show you one way that kind of works quite nicely, I think. So we've got these fractions, and 2 concepts come to mind for me. One, fractions look a little daunting, right? And 2, maybe they should all be fractions, and then the fractions will sort themselves out. So let's do this. Let's go, well, x is just x over 1. That's another way of writing it. Now it's a fraction. Plus 1 over x minus 3 equals x minus 2 over x minus 3. Okay. But when we add fractions, like look at these adding fractions, and we're going to do this for the whole equation. What's useful to do when we add fractions? I think it's quite useful to get an LCD. And let's note down what we're doing. Our lowest common denominator here is, we've got 1 x minus 3. I'm just going to put this in brackets so that we can see it nicely as one term. So I think our LCD is just x minus 3. Okay, so let's head for this and go, well, if we want to try this left hand side as over x minus 3, this plus 1 looks great. Plus 1 of x minus 3 looking good. The right hand side is already over x minus 3, and it's got x minus 2 in the numerator. What do we still need to multiply this 1 by to get to x minus 3? Well, we still need to multiply it by x minus 3. So what we do to the bottom, so it's like, let's see if this makes a bit more sense. Like we want that to be x minus 3, and what we do to the bottom we do to the top. Well, really we want to keep the fraction the same. So therefore that fraction's the same, so therefore this part here is x minus 3. Now we've got an equation, and we've got the same denominator on both sides. Now just as a quick one, because this is going to be useful. What value can x definitely not equal? And why not? Okay. If x is 3, then this denominator is going to be 3 minus 3, and that's 0. And we can't divide by 0, so x can't equal 3. So let's just make a note here. X definitely can't equal 3, because that's going to cause problems, right? Dividing by 0 we don't like. Okay, and as another aside that we're going to use, not aside, this is useful to go. Let's say I said that a over 5 equals 3 over 5. What's the value of a? Well, clearly a is 3, because like if the denominators are the same, surely the numerators are the same. I think that's good logic. So in other words, the denominators are the same here. So therefore the numerators, x minus 3 plus 1 equals x minus 2. It looks a little bit more manageable now, doesn't it? Okay, well, I think so. And let's multiply this x in. So go for it, multiply it in, and simplify that equation. Okay, so maybe you went like x squared, x squared, yeah, it looks like what we were doing. Minus 3x plus 1 equals x minus 2. You're like, okay, well, here's a trinomial, let's factor. No. Why are we not ready to factorize yet? Well, we factorized when the right hand side was equal to 0. So let's do that. Let's make one of the sides equal to 0. So to do that, we're going to need to minus this x, and we're going to need to add 2. What we do on one side, we're going to need to do to the other. So x squared still x squared, minus 3x minus x minus 4x, I think. 1 plus 2, 3. Okay. Now the one side, happens to be the right hand side, is equal to 0. So let's factorize. Bracket, 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 bracket equals 0. X, x. What are the other parts of these brackets? Oh, well, 3, we need to do 3 times 1. It's our only real option in integers. So, and we're going to go minus 3 times minus 1, minus 3x, minus 1x, minus. Cool, that works. So, we've got x equals 3 or x equals 1. How are we going to draw that parabola? Or maybe just write a yes or a smiley face if you can draw the parabola. Okay, so we're just going to draw the x-axis. And this parabola is a happy parabola, a positive x squared. It's got 2 x-intercepts. It's got 1 at 1 and 1 at 3. Okay, so let's just keep that link. Just draw that parabola. Oh, look, happy parabola, x-intercepts 1 and 3. Keep that idea. Okay, round 2. We've got, they're all fractions already. Great stuff. X minus 2, x minus 3, 2 minus x. Do you have any ideas at this stage? Yeah, maybe your ideas come and you're like, ah, I know how to do this. And then let's just bear me out then. Or maybe you thought, oh, maybe you got some ideas, but not sure. So let's see. This x minus 2 equals 1 over x minus 3. Now, 2 minus x looks so close to x minus 2, right? I mean, it looks really similar. It's not quite the same, but we can kind of make it look the same. So let's go, let's see how we could do that. We want 2 minus x to look like x minus 2. Now, this is a positive 2, and that's a negative 2. That's a negative x, and that's a positive x. So it's like they're all the wrong sign. So if we could make this should be a negative and that should be a positive, then it would be the same, right? 2 minus x, positive 2 minus x. But we still want it to look like x minus 2. So why can't we just, what do we just need to do? Okay, why don't we just put a negative in front of the whole thing? Look, negative x, negative times negative 2 gives us our positive 2. So in other words, this denominator we can write as x minus 2. This is 2. And there was a negative over here. So I'm going to leave this negative here. There's the negative. And we change this to go, oh, well, let's make that a negative. Now we've got a negative here and a negative here. Negative times negative. Well, that's just a positive, right? So we could write this as, let's write it in a different color so it sticks out, a positive. So this little thing here, we can call a switcheroo, because it's like they've switched around, right? Okay, maybe you remember that from last year, maybe not, but the switcheroo is so useful. So there's our switcheroo. Now we've got these fractions. We've got x minus 2, x minus 3, x minus 2. So let's make this all one fraction. What's our LCD? Let's do this in a different color. What's our LCD here? What's our lowest common denominator? Well, I see it as x minus 3, x minus 2. Just multiply these two together. Okay, so x minus 3, x minus 2. So in other words, this one we still have to multiply by x minus 2. What do we do on the top? Bottom we do on the top. So we've got to go this 1 x minus 2. And then for this one, we've still got that plus. We've still got that 2. And we still need to multiply this by x minus 3 on the bottom and the top. So we need to multiply that by x minus 3. So these two fractions on the right hand side, or the two right hand sides, are the same now. And let's say this side we also want the same LCD. So this did have x minus 2. So what do we still need to multiply it by? X minus 3. Okay, denominator is the same, numerator is the same. x minus 3 equals x minus 2 plus 2x minus 3. Keep working through it, and you should probably get 2 answers. Okay, so you worked through it. Well, I hope you did. And you got x squared minus 3x equals x minus 2 plus 2x minus 6. And you said, cool, not equal to 0. Let's rearrange this so it equals 0. Minus, we got x plus 2x is 3x minus 6x. We got minus 2 minus 6 minus 8 plus 8 when we plus 8 on each side of the equation. Okay, that's great because I'm sure we can factorize that. And you went x. I'm saying you went. Press pause if you didn't. And you got to a certain stage. Press pause and pick up where you were. And 8 maybe 4 and 2 minus 4 minus 2. So x equals 4 or x equals 2. Now, no. Why am I knowing? One of those solutions is not valid. Why? Which one and why? Well, look at this one here. X equals 2. What happens if we put 2 in? What's 2 minus 2? 0. What? Can you divide by 0? No. So therefore, we show that this was an answer and we cross it out. So we say there were 2 solutions, but one of them's not valid. Okay, let's see. Did we miss something in the previous one? X can't equal 3. Wait a second. We said x can't equal 3, and then at the end we said x equals 3. No, it doesn't. So, keep an eye out for that. Yeah, last bit. I'm not going to draw the parabola for that one. Our last bit. We've got a whole lot going on here. I just want to look at strategy. How many terms do you have in this denominator? We've got 3. It would be useful if it were 1 term. How do we turn multiple terms into 1 term? We factorize. Okay, so let's factorize and say, well, we're going to go bracket, 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 bracket. So it's going to be 1 term. Minus. How many terms do we have over here? Factorize. Bracket, 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 bracket. It looks like a difference of 2 squares. Equals. I'm guessing that there's going to be a switcheroo needed here. So I'm guessing that instead of minus x minus 1, we want it to be x plus 1. That be right? Change them both to negative. That negative to a positive, that negative to a positive, taking out a minus. So a minus for one of these brackets might be a plus 1. Okay, so work with that strategy. Try and find your LCD and just try that out. And then work through exercise 2.2, I think I said. I'll have to double check the page now. But I know I had K, I, M, and O. And I've suggested you do it in that order, just because K looks like those and I looks a bit different. So that's the order I suggest. Just 4 of those. Give it your best go. And let's take it from there. Goodbye.